All right, everybody, we are going to talk about equivalent fractions today. So we talked a little bit about equivalent fractions yesterday when the last lesson we had together, and when we talked about more names for fractions, or many names for fractions. So one of the ways that we did it was through manipulatives and then through drawing them. So for example, one of the problems on your worksheet was 1/3 is equal to 2/6. So if we have our model here of 1/3, so one of the three pieces are shaded. And then over here, we have the same model, but then what we're doing is cutting it horizontally to make two pieces out of the one, and then we now have 6 pieces instead of the 3. So these are equivalent or the same, okay? And same thing down here, we have 1/3 and 3/9. Okay, so now today what we're going to do is actually, instead of using manipulatives and instead of using drawings, we're going to use math. So equivalent fractions are just fractions that are equal to each other. So if we take the word equivalent apart, equa, meaning equal or the same. So equivalent fractions. Now remember, the parts of our fraction are, we've got a numerator on the top and denominator on the bottom. To make equivalent fractions, you can use either multiplication or division. We're going to start with multiplication first. So the first one we're going to do is 1/2. And to get our equivalent fractions, we are going to multiply the numerator and denominator by the same number. So I think of fractions like jealous brothers and sisters. So if you had your parents take your brother or your sister out for ice cream and then not take you, you would probably say, that's not fair. So the same thing with fractions. You have to do the same thing to the numerator as you do to the denominator. Otherwise, you won't get an equivalent fraction. So for this one, let's start just by multiplying by 2. And I'm going to write my multipliers up here at the top, just so that you can see what I'm doing. So I'm going to take 1 times 2, which is going to equal 2. And then 2 times 2 equals 4. So 2/4 is equal to 1/2. So just like when we drew it before, we had 1/2 like this. And then if we were to draw it this way and cross it out, cross it here and cut it horizontally, we would have 2 pieces shaded of the 4. So that's how these two relate. So this is the way we're going to do it now with our multiplication, to do it without having to draw it each time, because sometimes it's going to be really hard to draw fractions that are, ninths and tenths and 25ths and things like that. So going into the multiplication and the actual computing of all this is going to be easier now that we are getting a little farther into equivalent fractions. All right, let's try 3/6 equals, and this time let's multiply by 9 times 9 times 9. So 3 times 9 is 27, and 6 times 9 is 54. So because I multiplied the numerator and denominator both by the same number, I have an equivalent fraction of 27/54. So the nice thing about multiplication is you can choose any number and multiply the numerator and denominator by it and get an equivalent fraction. I could even choose 1,000,000. So if I had 3/7, I could multiply both of these by 1,000,000 and get an equivalent fraction. So 3 times 1,000,000 would be 3,000,000, and 7 times 1,000,000 would be 7,000,000. So 3,000,007,000,000. Holy cow, that is gigantic. So you can multiply it by anything. You could multiply it by, I don't know, let's do 22 this time. So 2/5 and so 2 times 22 is 44. And then 5 times 22, we can even do a little bit of side math down here if you're not sure. So 2 times 5 is 10, carry the 1. 2 times 5 is 10 plus 1 is 11. So we would get 44 over 110. So all of these are equivalent fractions because I multiply the numerator and denominator by the same thing. Okay, so let's do a couple of division problems. So that's multiplication. The nice thing about multiplication is you can multiply it by anything. However, division is a little different because you have to divide the top and the bottom by the same number. So it has to go in equally. You can't have remainders. So if we have 4/16, I know that these are both even. So I could divide the top and the bottom, or the numerator and denominator, by 2. So 4 divided by 2 would be 2. 16 divided by 2 would be 8. So that would be a set of equivalent fractions by dividing. I could also, so if I have 4/16, I cannot divide both of those by 3. Actually, 3 doesn't go into either one of them. So I could divide it, however, by 4. So that's another thing we could divide this by. So 16 divided by 4 goes in evenly, and 4 divided by 4 is even as well. So 4 divided by 4 is 1. 16 divided by 4 is 4. Okay? So that would be an example of using division. If I had, let's try another one. What if I had 5/15? So I would have to think, okay, what could I divide both of these by? So if we think about our divisibility rules, they both end in 5. So I know that both of them would be divisible by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. So 1/3 would be the equivalent fraction for that one. Okay, so if division is still feeling a little tricky, we are going to spend a lot more time on division when we get into reducing fractions in lowest terms. So don't worry if division seems a little tricky right now. We're going to get to it, and I'm going to move a little. We're going to work through division a lot in the next couple of lessons. But I wanted to make sure that I introduced both of those to you guys. So that is kind of the introduction to these two. And before we, well, we'll do kind of like a mystery here at the end, but I want to show you kind of the format of what your work is going to be for today. So the way that your worksheet looks today is it's a big chart. Okay. And there are lots of other columns in here. I'm just going to show you 3. So these are the first 3 on your chart. And what I want you to do for each one of the items on your chart is find 2 equivalent fractions. Okay, for each. And there's a direction at the top of it in red, just in case. Okay, so we're going to go through these, and we're going to do a couple of examples in here just so you know what we're doing and how the format of your worksheet looks. So for this one, 0/2, I could multiply it by anything. Let's multiply it by 5. So 0 times 5 is 0. 2 times 5 is 10. So 0/10. Let's say we multiplied it by 10 this time. So 0 times 10 is 0. 2 times 10 is 20. So that would be 2 equivalent fractions for that number. Let's go to the next fraction. So I have 1/2. Let's multiply 1/2 times 5. So 1 times 5 would be 5. 2 times 5 would be 10. So that would be an equivalent fraction. Let's multiply it by 9. 1 times 9 is 9. 2 times 9 is 18. Okay, so that would be 2 equivalent fractions for 1/2. 2/2. So here's the interesting thing about this fraction. If we were to draw it like this, the whole thing is filled in. So 2/2 is actually one whole, right? So this is it's just an interesting fraction, and we're going to have, the nice thing about this is all the fractions you're going to make here, the numerator and denominator are actually going to be the same because you're multiplying by the same thing. So let's do times 7 this time. So 2 times 7 is 14. 2 times 7 is 14. Let's multiply by 6 this time. 2 times, oops, hang on, saying 6 and writing 6. 2 times 6 is 12. 2 times 6 is 12. So this is what your worksheet is going to look like. It has about 15 or so columns like this. So you will, for each one, just make 2 equivalent fractions for each one. Okay, so that's your worksheet. Okay, before we go, I want to give you a couple of equivalent fraction mysteries that we're going to solve together. So if I have 5/12 or 5/12, and what if that's all I know about this fraction? How could I figure out my denominator? Now, remember, you have to do the same thing to the numerator as you do to the denominator. So we have some clues here. How would we get 10 from 5? 5 times what would be 10? 5 times 2, right? So now we have to do the same thing to the bottom. 12 times 2 would be 24. Okay, so you can use the clues from parts that you know to get to the other parts. All right, let's try another one. Let's do 3/8 equals, and we're going to have 32 as a denominator, but we don't know what the numerator is going to be yet. So 8 times what would be 32? 8 times 4, right? So then 3 times 4 would be 12. So our new fraction would be 12/32. And I know that sounds weird because it sounds like 30 seconds, but 12/32 is how you would say that fraction. All right, let's try one that would involve division. Let's do 16/20 equals 4/blank. So the way that we got 4 from here was 16 divided by what equals 4? So 16 divided by 4 equals 4. So 20 divided by 4 equals 5. Okay. And let's try one more. Let's do 27. This is going to be a tricky one. 27/72. And let's say our denominator over here is going to be 8. Okay, so you have to think. Now they're getting smaller, so we're going to use division here. So 72 divided by what would be 8? Divided by 9. So we have to divide the top by the same thing too. So our numerator, 27 divided by 9 equals 3. So 3/8 would be that fraction mystery. Okay, so now just so you know, your actual work today is not like this. I just wanted to kind of show you this just to give you a little stretch of your brain with equivalent fractions. So the problems you're doing for your worksheet are the chart. Make sure you do 2 equivalent fractions for each, and then complete your fast check. So your to-do list for this lesson is, you've watched your video now, go back to Classroom, check out the board notes, work on your worksheet and your fast check and submit it. And then after that, you have some optional stuff you can do. You can check into office hours. If you're confused on something or if you have any questions, I'm happy to help you out. There's also some optional IXL work and optional work for the week. So thanks for coming to the lesson, and I'll see you next